Okay, so while I'm waiting for her to join, hopefully she gets that this time. So we're going to follow through with this today, and I want us to be fast, even though I do not want our extra time to also exceed beyond 1:30. We're going to follow through with this. So the first thing we want to do today is to use discriminant. Look, we want to use discriminant. We all know what discriminant is, okay? To see the relationship between the graph and, okay, sorry, getting distracted. It still shows wrong password. What is this? Is there a way I could remove this password thing? Okay, that could be it. Hi, Karen. There shouldn't be any space in your password, even after the last digit, no space. Can you be more careful when you type in that? All right, so this is what we want to see. We want to see the relationship between your curve and the x-axis, basically, all right? Between your curve and the x-axis, that's the main objective here, okay? That's the first thing we want to do. Using discriminants, we've talked about this even in our previous lessons, right? If your discriminant shows equal rule, then it's cut twice, right? Do you remember this? If your discriminant shows 0, which means you have real and equal roots. No, this is distinct roots. This is real and equal root. It means it touches once. It could touch once above or below, like above, like touch like in this form or in that form. Do you understand? I don't think I typed space. Okay, now I'm confused. I don't know what to do. Are you all using downloaded app? Is anyone using the online version? Karen, could you download the Zoom app instead of using the web? Let's see, because Zoom changed some settings over the weekend, or maybe sometimes last week. Okay, so we want to see this is our aim, of course, today. If you have a complex root and it doesn't touch it at all right? So I'm gonna send you this screenshot so you can maybe take down some notes. So just write the topic as still quadratic, okay? So the first thing again is to use discriminant to test the relationship, okay? Another thing we will like to do today, if time permits, is how do we find a quadratic equation from the graph? So using from this graph now, how do you know what the equation looks like? Okay, and the last but not the least is a word problem. Oh, okay, before then there's intersection of graph. Okay, I don't think we will probably not get to this one. So let's go back to the first two. Okay, let's go back to the first two. Okay, so I'll show you this while I'm trying to help Karen fix something. All right, so I send you these screenshots. Okay, so take note of some important details if you need them. And here is another, and also a sample of what we'll be doing. Take note of that. So with this, I need you to attend some problems here. Okay. Just try maybe question 1 A, B, C. Okay, I'll be back, guys. Try question 1 A. Okay. Hallelujah. Where is she? Hallelujah. Hallelujah. I still can't see her yet. Miss K, where are you at? Or maybe your camera isn't working now.
Wait.
So funny. Okay, that's coming on. Okay, that's coming on. Has anyone seen her? Because I haven't. Okay, finally, there she is. Oh my God. That's so frustrating. All right. Okay. It's probably some bug, some installation thing that your computer has not been. So when you do some, normally you do updates, you have to restart your computer. Maybe that's why you're having those issues. All right. Okay. So what this part is talking about is positive, definite, and negative, definite quadratics. Positive definite implies that all the values, by values we mean the values of y. You know, we've talked about that in the past. In the case of vertex, maybe maximum and minimum, the maximum point consists of x and y, but the maximum value is just the y value. Do you remember that? We always talk about that. So when we talk about value, we are saying the values of y. So a quadratic is positive definite if and only if a is greater than 0. Okay, this is the one with value. If all the values, it is positive for all the values of x. It means the value of the quadratic itself is positive, which means y is positive for every x you can think about. Now, how can you have this? Let's come to the board and expatiate further. How can you have this? So you have your x and y, you have your x axis. So you can either have something like this or you have something like this. If you have this, all the values of y are positive. There is no way you can have this and all the values of y are positive. Okay? If all the values of y are positive, they must be here. You can't have this. Who can tell me why this doesn't make sense? Anyone? Come on, someone. Why can't all the value of y be, why can't we have the, because this looks like it doesn't touch also. And anyone tell me why this is wrong? This is not making sense.
Because eventually it will touch the x-axis.
Say that again, Leo.
Because eventually we'll touch the x-axis.
Thank you, Leo, because this is just some of it. It's extend indefinitely. Eventually it will touch the x-axis. Unlike the other one, it extends infinitely on both sides and it still doesn't touch. Okay, so this is not an ideal curve for that purpose or in this situation. Okay, so you can only have this, and you can only have this if you have a minimum that does not touch. So two conditions. It is a minimum graph and it doesn't touch means you have complex roots. Minimum exists when a is greater than 0. Complex exists when your discriminant is less than 0. Okay, another one is when you have a maximum that is complex. Maximum exists when your a is less than 0. Complex exists when your discriminant is also less than 0. So those are the two conditions. Does this make sense? And this is where, so here you have all positive, here you have all negative. So this is the positive definite, this is the negative definite, and that is what this note is trying to talk to you about. Uh-oh. Can you see that? Okay, so we should take note of this. A quadratic is positive definite if and only if a is greater than 0, but discriminant is less than 0. A quadratic is negative definite if and only if a is less than 0, but discriminant is still less than 0. In both cases, discriminant is less than 0. Just remember the definition, all positive, all negative, and I think you can always deduce whatever it is yourself. Okay? Any questions? All right. And that's some of the things that we need on the next page. Can you see this? Show that this is positive definite. Can I ask you to try it and tell me how you did it? Or just try it. Try A, B, one is positive definite, one is negative definite. Aha. What does this C mean? X squared minus this is greater than 0 for all x. What does that mean? What is that question asking? Karen? Can I ask Karen to answer that question? Can Karen hear me?
Yes.
All right. So this is clear. It says, do you understand what I mean by positive definite and negative definite, right?
Yes.
Okay. Can you tell me what this question is asking? It looks different. Do you understand what it's asking?
Not really.
Leo, this C part, do you know what it's asking us to do? No? Okay, I'm going to break you into rooms and I need you to talk together, all right? You have, just do A and D, all right? 5 minutes, A and D, breakout rooms. So I'm going to put you in rooms now, randomly. Automatically, let's have 3 rooms. Okay, I hope, yeah. How many people are using multiple devices? Only Clarissa? Is it only Clarissa using multiple device? I think so. Okay. So everyone, join the rooms. Join your rooms. I will send the screenshot to the WeChat group.
Oh, I think if A is positive, then it should be positive. If it's negative, it's a negative definite. And then you check with like the same as the other ones.
So you have to like make it into
Into what?
like square. No, you don't have to.
No, you don't do all that. The condition is there. Did you see what I sent on WeChat? The condition you need to check is there. Can I share?
Yeah. So you just check the determinant.
Look at the picture, the third picture above, where the definition is. You just have to check the discriminant. Even the example is clearly stated. Can you see the example in the picture, Karen?
Yes.
So that you don't do any completing the square or whatever. Just check discriminants. The 2 conditions. If it is positive definite, you have all positive. That must be a minimum curve. So A is positive. If it is negative definite, A is negative. Because it is only when A is negative you have maximum. Okay? So A is positive when it is positive definite. A is negative when it is negative definite. In both cases, discriminant is less than 0 because you must have complex root situation. So you only check two conditions, what is A and what is the discriminant, and make your conclusion. Have you been able to interpret what that question D means? Okay, discuss it among yourself if you don't know now.
Okay.
All right, I'll be back. Are we having a discussion here? Are we? Or everyone is just staring at each other's lovely faces?
We're doing A.
In A. All right, any questions so far?
No.
You know what to check, right? Just two conditions. What is A and what is discriminant? That's all. Someone was insinuating completing the square. This is nothing about completing the square. All right? Then I need interpretation of that greater than 0 and less than 0. Discuss it, then we'll come back together very soon. All right? I'll be right back. If you need me, you know what to do. Hello, room 3. Everything going on fine?
Yeah.
We're only checking two conditions. Everybody knows that, right? The value of A and discriminant. That's all you're checking. No completing the square here. You're only checking whether it is positive definite or negative definite in the first one. In the second one, you need to interpret what that greater than 0, less than 0 mean to you. Okay? You need to interpret that, and we'll come back to the main room and discuss, say, in the next 2-3 minutes. Welcome back. Clarissa rotated 90 degrees anti-clockwise. Okay, Clarissa rotated 90 degrees clockwise about some origin. Okay, more people are joining now. Okay, good. I think we have one more group. All right, looks like every group is here now. So can someone explain to me what this means to them? 4x minus x squared minus 6 less than 0 for all x. What less than 0 for all x? What does that mean? Come on. We don't have all day, guys.
It means that it will be a negative definite.
That's all. That's all. It's exactly this. It being negative definite means it will always be negative for all x. So the fact that the word negative definite was not used doesn't mean it is a different question entirely. I hope everybody got that. Please confirm if you understand that, guys. Okay, good. All right, so let's move on. So here are some other questions which you can try on your own, but I want us to move to this part. Now, this is another, we've talked about touching at one axis. If it's cut at one axis of x-axis, one point at x-axis, it means you have what kind of roots? What kind of roots, please? Hello? If the curve touches at one point on the x-axis, what kind of roots do you have?
Equal real root.
Equal roots, and that is when your discriminant is 0. Okay, so I hope you can see these examples. So find the values of k for which this function cuts twice. Cut twice means you have distinct roots, real and distinct. Okay, so you find the discriminant for all the questions. Of course, you have to, this is the beginning. Then if it's cut at 2 points, it means discriminant must be greater than 0. Okay, so first thing is to find discriminant and greater than 0. Or you could do it together from the beginning, like by doing this. So I could actually, that's my pen. Yes. So according to the questions, it says cut, okay, for which the function cut the axis twice. So I can start by just saying the function cuts the x-axis twice when discriminant is greater than 0. Do you agree? That's when you have distinct roots. So your discriminant is b squared minus 4ac greater than 0. So what I'm saying is you don't have to have b squared minus 4ac separately and form your inequality separately. You can write it together. Am I making sense? So then we substitute. In that problem, our b squared, I mean the example now, the function is x squared minus 6x plus k. Oh, is that miss k? Maybe. So b squared here will be negative 6 squared. 4ac will be 4 times 1 times k greater than 0. So 36 is positive minus 4k greater than 0. Please always leave the variable on the left-hand side. Don't try to take it to the other side and it might be, it's just an advice. It doesn't mean that's the only way. Okay, now if you divide by negative 4, you know the sign will reverse, right? And that will be positive 9. Okay, and that's all. That's all you have to do. You say find k for which that happens. Find the value of values of k. It could be one value, it could be many values. In this case, there are many values because this is k less than, it is a range. So it's not just one. That's why the question says value or values. Okay? That's why you have value or values. Am I making sense? So please, let's take note of this. So, and that's all this is about. Do I need to show some example or anything? Do I need to show example other than what you have here? Please speak up if you need me to show example. Karen, Leo, Clarissa? No? Karen, Leo? No? Okay. So if that's the case, I leave you with question 6 and 7. Okay, I put you in breakout groups. I send this to WeChat. 6 and 7. You have 10 minutes. Okay, 6 seems to be a lot of questions. Okay, let's do this. Let's do this. Do question 6C and 7. Okay, just 6C and 7. 6C, you have 3 questions. You find K when it cuts twice, when it touches the x-axis, and when it misses the x-axis. I will also send you this example. I'll send it to the WeChat group now, okay, before I break you into your groups. So here is the example. And here is the question. Okay, so you have to do problems 6C. So 6C asks Roman figure 1, Roman figure 2, and Roman figure 3. And do 7 as well in groups. Okay, so we're going to be going into breakout rooms now. Okay, I think you are going to retain your old groups, your old rooms. So I've opened the rooms. So join now and have your group discussion there. Please join your rooms, join your rooms, join your rooms and discuss. Callista is still here. All right. Done with 6? Good.
Yep.
All right. So see what you can do on 7, and now I'll be back. If you need me, you know what to do. Knock, knock. Anybody home?
Hello.
Where is Leo? Huh? All right. I'm sure you quickly maybe went to the bathroom or get some food. Okay, there he is, Mr. Leo. Are we done with 6 or 7 or both?
Not yet.
Not yet.
Which one is not yet? Miss Krista. Krista.
I'm doing 6.
6. 6C. All right. I hope we are talking together. If we get stuck, please make sure you talk together if you get stuck somewhere. I want this group activity to end by 1:15 so that the last 15 minutes, remember I told you we're going to extend a bit today. Do you guys remember that? Okay, the last 15 to 20 minutes, or I don't know if I said 30 minutes extra, but it may not need up to that. It will be used for the second part of the class. Okay, we wouldn't go to the last part of quadratic today. Okay, all right. If you need me, you know what to do. I'll be back. Anybody home?
Hello.
Everything good?
Yes.
Are we in 6 or we started 7?
Started 7.
Good. All right, so we're going to end this in 5 minutes so we can use the rest 15 to 30 minutes for the last part. Okay, today is the day where I said we extend a bit beyond the normal time because I want us to get somewhere. And that's the second part of the book that I need us to do, getting the equation from the graph. That shouldn't take us more than another 10 to 15 minutes anyway. All right? If you need my help, you know what to do.
Yes.
Welcome back. So, did you complete 6 and 7 together? Did every group complete that? Is there anyone who needs help with any of them? If you just need more time, say so. If you actually couldn't get through with something, please say so. Callista is stuck. Okay, she's here now. Hi, Callista. Is there anyone who has issue with any of the question? If you need more help, I understand that. But if you didn't know how to go about some stuff, please say it now. Anyone in that category? I believe none. Okay. All right. If you need to see the workings, I can take a screenshot of the solution and send to you later. Do you want me to do that so you can check with what you did? You guys want me to do that? All right. So I'll send that to the group later. Okay. So let's move on quickly to the last part that I want us to do today. Here we want to find the quadratic. You know, we've been dealing with equation, using equation to get the sketch, right? We've done that. Now we want to use the sketch that is given to get the equation. Okay, so that's what we want to do now. So look at these two examples. For this one, Nakita, do you need some time? Huh? I can hear you. I said, do you need some time? No? Hello, Nakita.
Yeah.
Do you need some time? I can see you are
Oh, no. I don't need it.
All right, okay, good. So everybody look at the screen now. Like I said, this is finding quadratic equation or the function, okay, from the graph. So basically, all you have is the vertex, just like the vertex, the intercept, and all that. And how can we use this information to get the graph? In this case, you are given the intercept and y-axis. And you are also given the fact that this is maximum. Can you see? So the first thing is to write in this form. Is everybody listening? Because I can't see everybody when I do this. So I'm only assuming that everybody is looking at what I'm doing. Okay, so the first thing is to write in this form. Because we know, remember the investigation that we did. Does everybody remember the investigation? Now this is where you use some of those stuff. So if you have it with two intercepts, definitely it's going to be in factorized form like this. Okay, so where if this is -1, there will be +1 in the bracket. If this is if this is 3, there will be -3 in the bracket. And A is negative, but we don't know what A is because the graph is going to be in this form. So that's what we have. Also, when x is equal to 0, your y is 3. Can you see that? When x is equal to 0, your y is 3. So if you substitute, you discover that A is -1. So all you have to get is value of A because you already know what the others are. And this gives the equation of the graph. So that is one case. The case where it touches at only one point, we discover it is always of this form, correct? Do you remember this? Okay, we discover it is always of this form, okay? Do I need to write something on the board for each of these, or you can just take a note out of this? Talk to me, please. Do I write on the board, or you can just take a note out of the examples?
I think we can just use the example.
Does everybody agree with that? Okay, what I've just written isn't much anyway, so you can just make a note like this. So if you have the form that crosses, you know it is of this format, maybe x plus m, x plus n, something like this. If you have the form that touches, then you know it is of this format. Okay, and if you have the form that does not touch, this is what? The complex roots version, right? Okay, then you can also have vertex. I think that's the third one I'm about to explain. If the vertex is given, then you know you have to do something like x plus m plus n, like that. Okay, if the vertex is the given one. Remember, if you're given a vertex coordinate like maybe 2, 3, then you know that your 2, this will become -2, and this 3 is the value of n. Am I making sense? So in each of these, you have to be able to figure out A, basically. So let's go back to the book. Okay, so for this one, look at this. You see, x is equal to 1 is given at the vertex. What does that mean? And also, you don't know the second coordinate. Oh, look at this. We have x is equal to 1. You know this is a line of symmetry, right? If this is a line of symmetry, the gap here is 3. It means the other gap is also 3. Can you see that? Right? Talk to me, please. Okay, so if the other gap here is also 3, then this has to be 4. So the equation becomes this again. Again, it looks like you are given this, right? The axis of symmetry format. Instead of giving you 2 coordinates. This you have 2 x-intercept and y-intercept. This you have x-intercept and y-intercept. This you have 1 x-intercept, 1 y-intercept, and the axis of symmetry. You can use this axis of symmetry to get the other one because this is the midpoint. From here to here is 3 units, then this has to be 3 units, and that's what was done here. So it becomes question of the first case again. Does that make sense? Okay, I don't know if you are not given the coordinates. Okay, if the coordinate is not given here, but that's the one I'm trying to explain on the board. I take you back to the board. I'll send all this to you as screenshots. If you have the coordinates of this, for example, as maybe P, Q, What I'm trying to say is that this is a, x plus h, remember this, all squared, plus maybe some k. This x is equal to p means in this bracket you had x minus p, right? In this bracket. And this q is the value of y. Okay? And here you will be given the y-axis, the y-intercept. With the y-intercept, so if you can substitute all this, you get y equals a x minus p plus all squared plus q, right? Now these are numbers already. The only unknown is a. And with the y-intercept, you put x is equal to 0. If you put x is equal to 0, you equate it to your y-intercept. So maybe this is y1. Okay, then it will be y1 equals a 0 minus p all squared plus q. And this is how you get the value of your a. Then you can substitute back into the original format. Am I making sense? Nakita? Okay, Lillian, Clarissa, Karen, Leo, Crystal, Vena and Callista. Everybody understands? Okay, good. So this form is not indicated, but if you come across it, this is what you do. So basically, we're reversing what we learned last week. I hope everybody gets that. We're reversing what we learned last week. From equation to the graph, that's what we did last week. Now we are dealing with from the graph back to the equation. Okay? So let's go back to that book and see some. I'll send you this now to the WeChat group. Let me send this to the WeChat group now before I proceed. So just give it another heading, forming an equation from the graph or something like that. Okay, let's start with this one. This is finding equation from the graph. Quadratic, of course, quadratic equation. Okay. So now I'm going to send this to you. So I'm going to break you into your room now. Let's see. Okay, here is another one. We'll leave this. Here is another one. Can everybody see this? I don't know if we could just go through with this, then you can take your time to do practice on your own. So here is another one. Find the equation of the graph whose, look at this please, find the equation of the quadratic whose graph cut x-axis at this point and passes through 2 minus 20. Can you see that? So here, you are not given just the y-axis, y-intercept. You are given another point on the graph. Everything is for you to be able to get the value of a. Do you agree with that? It's just for you to be able to get the value of a. Because initially you have when x is equal to 0, y is equal to something. That's your y-intercept, right? But now you are given a different point entirely on the graph, something like this. It's like giving you, instead of giving you this y-intercept, it's like giving you this point, or maybe this point, or maybe this point, just a random point. Okay? So rather than putting x is equal to 0, y is this value, simply x is equal to whatever, y is whatever. So it's the same as the previous one. Please confirm if that makes sense to you. Yes? Okay, good. So that's all this is about. So it looks like a word problem. Okay? So also I will send this to you. Then this is another, this is the vertex one we've just explained together. We've explained this, right? So if you have it in form of a vertex, you use this form, okay? Always write that form. Always write this form here. This one. Always write this first. Okay? Maybe I write it properly. If the question is in vertex form, first write y equals a x plus h squared plus k. That's the form. We've mentioned this before. Maybe while you're working in your group, I'll write a summary if you need me to. If you have, okay, let's say the form, the type of question or type of situation you might have. I'm not saying you should write this, just pick whatever you need, the forms to use. Okay, if you have two x-intercepts, okay, if you have two x-intercepts, you use this form. Y equals a x plus p x plus q. Of course, and any point. And any point. It doesn't have to be the y-intercepts. It could be any point, because any point can be used to get your A. All right? Any point has x and y, and that can be used to get your A. Does that make sense? So if you have that, if you have one x-intercept and any other point, then you are going to have a x plus p all squared. If you have vertex and any points, of course you use y equals a x plus h all squared, then plus k. Okay, the other one is also part of this, that other example where you have one x, one y, and the axis of symmetry. Okay, one x-intercept, axis of symmetry, and any points. You still use the first one, because the axis of symmetry allows you to get the second one. So actually these two should have been together. So I should have labeled it as maybe the first, the second, the third, and the fourth, something like that. Does this make sense? So feel free to use any of these in your notebook. So I'll send you the screenshots and the questions that follow. And this is all we want to do about sketching graphs. So you could see the, okay, you can't see this yet. Okay, can I check the screen? Can I change the screen? Karen? Okay, Leo? All right, okay. So I change the screen quickly. So you could see the format, so just state that format first, the format in that table. State that first, then substitute what you know. With this 3, you're going to have -3. This -2 does not change. Do you remember that? That if you have it in this form, this -2 is the y value. When this bracket is equal to 0, you get the x value. So when this bracket is equal to 0, x is 3. So 3 doesn't change. But this 3 changes, but this does not change. And using this intercept, you can always get the value of A, and that's it. Understood? And for the second, you see you have this and any point. This is any point. So this is x is -2, y is 0. And that's what you have here. That's why I didn't say y-intercept. It could be any point to get A. Okay? And you don't have to expand. You can always leave it in this form. Understood, please? Please confirm if you understand what I've just said. All right, so I'm not going to ask us to go into breakout groups. It's already 1:35. I believe we can practice on our own. I'll be sending all this in order into your WeChat group, and I'll identify which needs to be submitted as a graded work, so that when we come next time, we simply just go back to this part, and after which we can go to the word problems. So word problem is the next thing after this. And you see word problems. After the word problem is optimization, which we have already done. And after that, we can kick that goodbye. We are done with quadratic. Then we can move to cubic functions. We'll look at quadratic inequalities later. I want us to do the functions first. Quadratic function, cubic function. And if I think we should go to maybe quadratic inequality, then maybe we can take it together, okay? But I'll let you know. Any questions, please? All right. Questions from anyone before I close the class? No? Okay, so immediately I close this lesson, I'm going to start sending you the screenshots. If you have the time now, please take note of the examples while you are doing your work. Arrange it in order so you know what to do. So if I send you the first one and the other example, I'll be sending the screenshots with the questions and the questions to attempt, okay? So don't copy all the examples and then you start doing the work. Do them in order. So for this specific type of example, let the question follow. That will help you to learn and remember what to do. Okay? All right, I'll see you guys on Wednesday. Bye.